Nitrogen is an essential building block of plant growth and essential to agricultural production, but the dinitrogen molecule that makes up so much of the air we breathe is not immediately available to plants. Over the years, farmers have used various strategies to add nitrogen to the soil for plant growth. For most of farming history, one of the main strategies to add nitrogen to the soil, aside from animal manure, has been what are called green manure crops. But over the last century, farmers have increasingly used manufactured fertilizers to achieve this goal. Commonly applied synthetic nitrogen fertilizer is manufactured using the Haber-Bosch process. This process, which uses high pressures and temperatures to combine nitrogen from the air with hydrogen, revolutionized agriculture in the early 20th century, but it is also the world's most energy-intensive industrial chemical reaction requiring enormous amounts of fossil fuels. Globally, the Haber-Bosch process consumes 3 to 5% of all natural gas produced and 1 to 2% of the world's total energy supply. It also emits more climate-altering carbon dioxide than any other commodity chemical and is responsible for 2% of global annual CO2 emissions. The fertilizer produced from this process has helped drastically boost crop yields, but it's also a key reason why agriculture is a major contributor to climate change. While all plants need nitrogen to grow, it's vital that current agricultural systems reduce their greenhouse gas emissions while still maintaining crop productivity. There are, however, other ways to harness nitrogen and make it available to crops while significantly cutting emissions. Green manure crops, such as red clover, are a subset of cover crops capable of converting nitrogen from the air into a form plants can use, a process known as fixation. While some fossil fuel usage is needed to plant green manure crops, the amount required to produce the same level of nitrogen is much less than for commercial fertilizer. Creating nitrogen fertilizer requires vast quantities of fossil fuel-based energy, whereas legumes and green manure crops, such as red clover and alfalfa, use sunlight. Green manure crops are typically planted the year prior to a cash crop. For example, red clover can be seeded in the spring, either with spring-planted small grains or into an existing overwintered small grain stand. The clover germinates and grows, and after small grain harvest in the summer, it continues to grow and fix nitrogen. That nitrogen builds up in the clover's shoots, roots, and leaves. In either the fall of that year or the spring of the next year, the clover is killed and a commodity crop that demands large amounts of nitrogen, typically corn, is planted. As the red clover decomposes, nitrogen-rich compounds are broken down by soil microbes, eventually resulting in forms of nitrogen that are available for other plants, like the cash crop, to take up. The most effective way to incorporate red clover and other green manure crops into Corn Belt commodity row crop agriculture systems is by pairing them with small grains like oats, wheat, barley, or rye, or by using them as forage crops for livestock. Alfalfa, or a mixture of alfalfa and grass, is another crop that can act like a green manure crop, but whose main purpose is for forage or hay for livestock. In that case, the hayfield is similar to a pasture. After planting, it's usually left in place for 2 to 4 years, fixing nitrogen throughout that time period, and is cut 3 to 4 times per year until its productivity diminishes. The alfalfa or alfalfa grass mix is then killed, and a crop that requires a lot of nitrogen, like corn, is planted the following year. In both cases, the green manure crop adds ample stores of nitrogen fixation powered by sunlight. These crops also prevent the soil from eroding and protect water quality by growing when cash crops across much of the rest of the landscape are not. Because living roots are needed to suck up excess nitrate in the soil and keep it out of surface water, green manure crops pay many dividends back to the landscape beyond significantly reducing the greenhouse gas emissions linked with synthetic fertilizer.